This is Into Math 3rd grade, lesson 11.5. Represent rectangles with the same perimeter and different areas. I can use area to compare rectangles with the same perimeter. Please gather your workbook and a pencil and turn to page 320. You can pause at any time. We will start at Step It Out Part 2. Fran buys rectangular clay tiles. The perimeter of each clay tile is 18 inches. Part A, draw all the different rectangles with a perimeter of 18 inches. Let's review again that the word perimeter means the distance around the figure. And so we want to be clear that we're not looking for area, but we're looking for perimeter. So if you would like to pause and try drawing all the different rectangles in the grid that's provided, just remember that 1 square equals 1 square inch. Otherwise, you can definitely follow along with me. I'm going to start by creating a rectangle that has just 1 square inch. And then I'm going to color in a total of 8 square inches. So if you want to pause and do that, you may. And what you'll find is we have 1 square inch as the width, and we have 8 inches here as the length, another inch here, and then 8 here. So that means we have 8 plus 1 plus 8 plus 1, which makes 18 inches for the perimeter. Okay, so if you want to pause and try the next one, which I'm going to go ahead and make a rectangle with the width of 2. If you want to try that on your own, you can do that, or again, follow along with me. I'm going to have 2 colored in here, and then I'm going to count for 7 squares and color those in. And then I'm going to show you what the perimeter is. So we have 2 square inches here, and then we have 7 along this long side, another 2 here, and along this side we have 7. So we have 2 plus 7 and 2 plus 7, which makes a perimeter of 18 inches. I'm going to move on to 3. So we'll do 1, 2, 3. So we'll color in 3. And then we will go add 6 more squares total. 1, 2, 3, 4, 5, 6. And we'll just color in the rest of this. So here's another rectangle that we can create. And then again, I will show you the perimeter together. So this part would be 3, which is the width. And this side length here would be 6. This part would be 3. And this length would be 6. So we have 3 plus 6 plus 3 plus 6. Okay, our next one, we're going to have 1, 2, 3, 4. And we will color down to 5. And then we will have a width of 4, a length of 5. And the other side here will be 4. And this length would be 5. Which makes a perimeter of 18. So now let's take a look at part B. And the reason, again, we're stopping is because if we go to 6, we've already made a 6 here, 6 and 3, so we can stop there. Okay, so now let's take a look at part B. Find the area of each rectangle. Write equations. We can remember that area is the measure of the number of unit squares needed to cover a surface. The first rectangle we created had a length of 8 by a width of 1. And if we count the amount of squares, 1, 2, 3, 4, 5, 6, 7, 8. So we find that there are 8, which means there are 8 square inches. Our next rectangle has a length of 7 and a width of 2. And we find that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14. So that means our answer is 14 square inches. Now we'll take a look at the third square we made. If you would like to pause and try the last two squares, finding the area on your own and come back, you're welcome to do that. The next square, the length is 6 inches by 3 inches, and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. So there are 18 square inches. Our final rectangle had a length of 5 inches by 4 inches width, and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. There are 20 square inches. Let's look at part C. What is the difference between the length and the width for each rectangle? Write equations. So we are going to create subtraction problems because they're saying use the difference between the length and the width. And so we will do each equation. So we will take the length, which is 8, subtracted by the width, which is 1, and we will find that for this equation, the answer is 7 inches. Then we will take a look at our next equation. We have 7 as the length and 2 as the width. And when we subtract 2 from 7, we will get 5 inches. If you would like to pause and continue to do the last two by yourself, you can do that, or just follow along with me. Next, we have 6 as the length, subtract 3, the width, and we find that the answer is 3 inches. And finally, we have 5, which is the length, subtracted by 4, which is the width, and we have 1 inch as our answer. Now let's look at part D. What are the side lengths of the rectangle with the least area? Explain the difference between the side lengths. Well, we will go back up to look at the answers, the products of when we multiplied the length by the width. And when we find the least amount of area, we find that the rectangle was actually this 1 by 8 here. That created just 8 square inches as the area. So we can explain our thinking. 8 inches by 1 inch is the rectangle with the least area. And then we can explain the difference between the side lengths, which we found here. 8 take away 1 is 7 inches. The rectangle with the least area has the greatest difference in side lengths, which was 7 inches. Please remember you can always go back and re-watch this video and pause along the way anytime as needed.